And this seems to be the one that I can bridge off of. And so, if you haven't read it already, Deep Green Sustainable Building Practices was a extended studies course that I taught in the evenings, March 23rd to April 20th in 2011. And so we'll kind of go through this. And our bigger, just to recap that, we're going to go big in this and come down, and by the end of this, if you still have questions on some of this stuff, then we'll definitely answer it. Then we're going to actually talk about bales and some of the tools and things. I can reference some of these pictures through the show, and I'll also talk about the finishes of what we're doing in this house and what we've done on other places. So plasters that go on it, floor finishes, exteriors, and then we'll get right into this, and so we'll finish and be stacking. So, any questions so far? The bathroom is the little blue office rocket ship out there. Don't push the red button on the right. Good. So, who's who and who'd you end up with? This is me. This is my dad. We had an addition put on because I have a little brother, and that is the biggest number one survey is people that put additions on their house because of little kids. I made that up, but anyway, so when I was a kid, we had an addition put on it, and I was really inspired watching this one particular old carpenter. And I never realized why I always wanted a red pickup truck until I found an old picture of this guy's Ken's truck parked there. And so that was, pre 4 years old on that. And the other thing is these two pictures are inspiration for me because who did this when they were a kid or something like this? Yeah, everybody does this. Do you know how dangerous this is? Do you have any idea as a parent how disconcerting that is? There's no, we should get building code on that. Part of it is that, humans are really resilient, and we also have this inner drive, this place, I call it the place of forts. We all want to build little places on that. And so we'll go through a brief tour of natural building. And natural building is, it's all kind of natural if it's from the earth, but natural building is really working with nature closely and trying to not manipulate it too much. Trying to keep it close to the source. And the other thing is, my basic tenement is natural building. If you eat it, will it kill you? That's a really good thing, actually, for everything in our lives. And so we all know kind of these histories from our indigenous people up north. They found appropriate things, and that's a really important thing with natural building, is they don't have the ability to use straw, so they use what they have. And we see these different types of dwellings all across the world with the appropriate material. And I believe this is 2,500 years old. These old foundations of clay, sand, and straw mixed together on that. Stone dwellings, people carving out places in the stone, more stone dwellings, and just beautiful. I mean, these are still there, thousands of years later. There's whole cities made of natural material. This is not sheeted plywood walls. This is clay, sand, and straw. This is dirt. And they're tall. They're skyscrapers. This mosque, this mosque in Mali, every year they recoat this with a fresh coat of clay plaster. And they actually have this little swampy area that, it's not really swampy, but there's one person that goes out and tests that clay. And it's an elder, and they test it, and when it's just fermented just right, then the whole village comes together, and they put a new coat of a clay slip on this building. And so it brings community together, and this is preserved for a very long time. All of these little abutments, these little pieces of log sticking out, what do you think they're for? Structure. To stand on. You can find videos of this being done. Eventually I'll get one. But they throw it up, and there's people standing on these, and they throw this up, and the whole town is there, and they're all participating. Great Wall of China. There wasn't anything here that was purchased from Home Depot, I promise. All of this mortar that's in there, this mortar was done before the invention of Portland cement. So concrete, what we think we can't live without, was not around at this point. So that's actually lime, and I'll talk more about lime. Anasazi dwellings, I mean, these things are so cool, you know. And so people were able to use the material. So beehive houses, and so, you know, there's this common theme that goes through, and different structures appropriately for different places. You know, if you go into the long houses of the northeast, of the woods, the deep woods, or if you go up to the northeast. And so part of that culture, but it's all natural building. It's all what they had available to them. And their buildings were appropriate. And that appropriateness is one of the most important things that we really consider and run through when we ask questions. Is what's appropriate? Is this appropriate? And so for the Plains, Native Americans, to be able to move was really appropriate for them. And so that was a really important thing. Whereas we had other people that were settling in an area where, you know, they didn't need to move. They weren't following herds. And so they built with the local resources that were available. And it's the same here. Again, we have a nomadic, moving culture still living in these things. People love these little yurts. So beautiful. Taos Pueblo, down in Taos. 1,000-year-old, continuously inhabited. People are still living in it. And it's adobe. It's cob. It's clay, sand, straw. That's all it is. Dug from the earth, right there. The entire buildings, they're beautiful. And if you grew up here, then you learn how to do this. And every couple of years, they go put a fresh coat on this. A fresh coat. And the times I've been there, there's been one time, actually, there was a group of boys that were all there. And they were singing and talking and telling jokes, and they were the younger boys, and there was one older guy that'd come in and check on them, and yeah, keep working, you know, they're kind of goofing off. But so they learn this, so this knowledge is passed down. This is just down the road in Bandelier, and Bandelier is abandoned now. There's nobody there. But so these stone foundations, though, this is all stone, clay, sand, straw, and this was all a little village, and these foundations are still there. And me being a mud dork, I came in, and this is adobe. This is clay, sand, straw. There's nothing protecting this. Nobody's actually coming in here and upkeeping this. And this is still very much intact. So there's buildings in upstate New York made of clay, sand, straw. So this is, again, using natural materials as insulation. That's there, you know, so we're back in the 1830s. You wouldn't know it looking at it. You don't know what's behind the walls, just like you don't know what's in a Twinkie. Twinkie, very similar. Again, just another example of, you know, we used materials that were locally and readily available to us that were appropriate to do the job that we needed to be done. So the natural fibers that happen is, we talk about adobe, cob, and light straw clay. Adobe, so there's really three things. There's clay, sand, and straw. And the amount of clay, sand, and straw that we use and how we put it together, the assembly of it, gives it different names. That's all it is. And so if you take a lot of clay and sand and a little bit of straw, and you take it and long straw, and you get it wet, and you stomp on it with your feet, and just make this stuff, then it comes in, and that long straw really gives it a lot of tensile strength, and you just stack it on top of itself and make a wall. That's called cob. And so you're free-forming, and you can do these beautiful curves and hobbit houses. This is how Frodo would have built his house. So you make these little hobbit houses. If you take that same material with a little bit shorter straw, and you put it in a form on the ground, build a little form, and let the sun dry it, make it into bricks, it's called adobe. And we call it adobe floors. They're earthen floors technically, but this is an example of an adobe floor, which you can come and touch on that. It gives it strength. It gives it that tensile strength that it's looking for. It's the rebar. It's the rebar of the natural world. And so in light straw clay is actually where you take you take clay and water and you mix it like a salad dressing, kind of like heavy whipping cream, and then you break a bale open or take long straw You don't need a bale. You take long straw and put it in there and toss it like coleslaw. It's just like coleslaw. And then you take and put a piece of wood on one side of the wall and a piece of wood on the other, and then you fill that cavity and you stomp it in there and you let it dry. And then you pull that wood off and move it up, and that's called slip forming. So you just, and you can do about 2 feet in a day. And you do this light straw, and then you peel it off, and that's an insulation at that point. So like those old buildings in New York, those old houses, that would have been the type of insulation that they would have used. We can go back into Germany 5 centuries and find buildings that are beautiful timber frames with light straw clay on the inside. So it's really, on one end of the spectrum, you have something like cob and adobe, which has a lot of sand and a lot of clay in it, but just a little bit of straw. There's a lot of mass. Really great for absorbing temperatures, whether it's cool or it's heat, and it'll store it and slowly give it back. But doesn't have great insulation. So we have lots of mass on one end of the spectrum, and then as we go down through that spectrum, we see something like light straw clay, which actually has some clay. It has some clay in it. And then if you go on to all the way over to just straw, there's really not a lot of mass in here, the mass of the straw, but there's a lot of insulation, and if it's really tight, there's a lot of insulation on this. So it's really the assembly of those materials. So clay, sand, straw are really the big things. And so this building here, this would have been a light straw clay timber frame, that's 4 or 5 centuries old. And then the outside is lime. It's a lime render, lime plaster, lime stucco. So looking at straw, these are a picture of the guys that brought us this straw. Straw bale and types of straw. Straw's been around for forever, and we'll talk more about it. But straw bale building, it's an American invention. It's an American invention, and the reason why we don't see really old straw buildings before mid-1800s is because of the invention of the baler. It was the baler that gave us bales, and it was the folks in the sandhills of western Nebraska that had to find a place to live, and so they took sod and stocked that up. They took hay and made hay houses, and they took straw on bales and they stacked it up, and they didn't use any timber. They just stacked it up. They built a roof, let the weight, and when the train tracks were going to get built across, they figured they'd finally get timber long enough, because there's nothing, the trees are this big, so they couldn't have anything. So they were going to wait for the train and build a house. So that's where it was invented, and it's been around since the late 1800s. The oldest known straw bale house as of about a decade ago is in Alliance, Nebraska. And we haven't had confirmation that this house is still there. The property went through new owners, and it was a little bit trickier to contact them. But this house is the Burt Gilman house. It was built in 1903, abandoned in 1956. So these folks built this house and said, wow, this is nice. And they stayed in it, because it's energy efficient, it's comfortable. And when this photo was taken in 1994, the straw, keep in mind it had been abandoned for quite some time, the straw was still as dry and as golden as the day it was put in the house. So it can be preserved in there. It's a clay plaster on the outside, and the reason why it got abandoned is because the dirt road that is by this house, well, the highway department came through and started building new roads. And they built a highway or a main road on the other side of this ranch. And so all of a sudden they were cut off. So at that point they went and built the conventional house at that time close to the road, and that's how that became abandoned. There's a little church in Arthur, Nebraska. You can still go to church on Sunday mornings in this church, a little straw bale church. This is a neat one. This is this big mansion in Huntsville, Alabama, and it's on the Register of Historic Places. 1936, and you wouldn't know it being inside that it was straw bale. Looks like a big old Victorian, or on the outside. It's sided, it's cladded, but it's straw bale. So some really neat places. And I'll read these up and I'll kind of go through theirs. There's a few of these narrative slides. The totality with which we have committed ourselves to fossil fuels is astonishing. From food production to transportation to building and heating our homes, virtually no part of the modern industrial life is unsupported by oil. And that's an architect named Wayne Bingham, who is a straw bale advocate and lives in a straw bale. The official solution has been to intensify production, expand oil exploration, and increase subsidy, which has been met with the same success as eating more quickly has on food shortages. So we're kind of following the wrong stuff here. And really what comes down is that natural building fell out of favor, not because it was inferior. It fell out of favor because it was labor intensive. And we'll get into that, but it was labor intensive. So human energy is something that really counts. So, this is both of these, I took these pictures walking behind these people. This is on a 3-day trek in the Himalayas in Nepal. That's how they get lumber up there. There's no roads. And yet you get up there and there's a whole village. And that guy's wearing flip-flops and carrying it on a head strap. So, we really sell humans short on a lot of this stuff. And so we started outsourcing because we are clever. If your choice was to carry it on your head or you ended up being lucky enough to trade to get a horse, now you're going to outsource. And now what do we have to work with, to do? We have horsepower. And now we have horsepower. And let me ask you this, is there ever enough horsepower? Well, horsepower can do what a lot of people do. And so it's the horse and it's the humans being able to create ways to do things faster, which is all out of a very good intention. It really, a lot of it, I believe, all of the world and the way we got to where we are, all the good, all the bad, was all started with good intention. I have an idea how to make this go smoother, how to make this more enjoyable, how to not, go home so sore at night. Robert F. Kennedy Jr. said that the last energy crisis previous to oil was the proposed abolition of the slave trade back in the late 1700s. Our founding fathers chose to remain silent about that because although they believed it to be immoral, it was felt that we were economically embedded into this free source of energy, human slave labor. It was seen as economically unfeasible to wean ourselves off of this energy source as a burgeoning country. RFK said that England took the lead and abolished slavery first, and that rather than an economic hardship, it became an economic boom. Jobs were created and manufacturers paid what was necessary for raw materials. England rode the crest of that economic boom while the U.S. fell into a civil war because we could not see the future, but we could see the future, but we couldn't act on it. Sustainable building is a step towards prosperity that awaits us. And so it requires a paradigm shift, as many people acknowledge, and we see it in our political landscape today. Go watch the news tonight or CNN. There's such diversity and opposite ends of the spectrum, and really what people are balancing is this: I want the paradigm shift. No, I don't want the paradigm shift. And it's hard. It's hard to make that paradigm shift. A profound change in fundamental model of perception or events. And that's what we have to offer in this sustainable building world and little revolution. The Industrial Revolution. So here we go. We got horsepower. Where all of a sudden horses get replaced with little tractors. And so now we're even faster because we're no longer using horses. We went bigger. We're using dinosaurs. We're digging them up and getting them out of the ground. And here they are. So all of a sudden we found black gold. And man, this stuff has just changed the face of the planet. And so this Industrial Revolution, go, build, build, build. And so one change, all of a sudden we go faster and faster and faster. So what I've learned is don't be afraid. Make the change. and then deal with the problems that are going to come as a result of that, because we see that through history, and eventually we'll get there. And this industrial revolution, this is in India. I taught in India for Bharat Petroleum, which is kind of like Exxon in the United States. They're the largest oil producer, and so they want to join this thing. Everybody wants a car over there. Everybody wants, concrete houses and wants running water and clean. They want the same thing we do. And so we see it faster and faster worldwide. Nature becomes a resource and a fuel for the industrial growth machine. So we're actually using nature. So the faster we go, the faster we're actually doing that. And so we get into production. And we've got these lumber mills. I mean, this is beautiful. Now you don't have to go out to the forest and cut your tree down and skin the bark off it. You just go and buy it. And we've got the we can do it mentality. And we have a baby boom. And so dig up the dinosaurs, feed the people, move it faster, and get the people comfortable. And all of a sudden, they start having more babies. Plenty of food and shelter. If you give people food and shelter, guess what's going to happen? They're going to reproduce. So there's a lot of reasons behind this little baby boom that happens. But the interesting thing in that time period for me is the first green revolution had to do with food. So the green building movement is, the green movement was done in food at first. And that was to produce more food for more people. And the post-World War II dream, which was come home from World War II, well, you'll get a house in suburbia, you'll have a white picket fence, and the American dream. And that was a beautiful dream. Suburbia, it's the post-World War II dream, a payoff to soldiers upon their return home. And rightfully so. So, in 1946, 500,000 homes were built. In 1947, 1 million homes. And in 1948, 1 million homes. That half-century dream is the greatest misallocation of resources in the history of the world. Americans' post-war wealth developed a dead-end lifestyle in suburbia. They lost connection with living things. And we could say a lot of great things about it, but in reality, we made a turn away from the natural world. And we made that turn into high-production housing. And so post-World War II, we had all this manufacturing for wartime. And what are we going to do with it? Well, now we got a bunch of people coming home. We got baby boomers, and let's turn these manufacturing jobs, let's turn them into housing. And all of a sudden, we found all kinds of different ways to use previous things. Fiberglass insulation. It was an air filter at first. We see chemical corporations involved with the military-industrial complex also participating in homes, in home building. We see just mass manufacturing be able to produce this stuff faster, faster, cheaper, cheaper. And so we get these big modern houses, which if you had to cut all of these boards down from a tree, your roof probably would not look like that. And so as we build more, and as we industrialize this thing, we've had the development of codes. More and more and more and more codes. And so the codes have a lot of really good ideas. Fire safety, structural integrity, means of egress, which means to be able to get out of the building if for any reason. Light, ventilation, heat, wastewater, electrical, gas, energy efficiency. But there's a bigger picture to the codes. And if we tried to enforce the codes on every structure around the world, there is not enough resources in the world to do that. And so what the code doesn't look at, and really, having a building code means that you are in an affluent society. And what it doesn't look at is it only looks at this, but there's all these unintended consequences as a result of holding such high standards and this industrial machine. And so we're not looking at the toxicity of materials. We do little tests on them. We're not looking at the heat island effect, the transportation, loss of agricultural land. So there's a lot more that's unintended around that. And our buildings consume 37% of all energy used in the United States, 68% of all electricity, 12% of fresh water, and 88% of potable water supplies. So our buildings use a lot of energy. So it's not just what we do to produce the materials to build it, which is a lot of embodied energy and a lot of carbon, but to maintain them for the rest of their life is quite high as well. So they generate, as a result of buildings, they generate more than a third of the municipal solid waste. 30% of human-generated CO2 emissions are from buildings. 46 of something else. What's SO2? Sulfur dioxide. And NOx? Nitrogen. I knew it in 2011.
Nitrogen oxide?
Bad stuff, noxious stuff.
Yeah.
The Union of Concerned Scientists ranks housing as the third most destructive human enterprise after transportation and agriculture. Oh, that's depressing. Worldwide, the building sector accounts for 30 to 40% of global energy use. So pretty big to keep our buildings heated and lit and all of that stuff. Embodied energy is the total energy comes from the embodied energy and the operating energy. So all of the embodied energy in order to keep your house going. So to build this house, the embodied energy in this straw bale right here starts all the way down into the dirt that this was grown in any fertilizers or anything that needed to be done to that dirt, the tractor that tilled over the field, the fuel that he used, what the farmer ate, who he bought it from, what they had to do to get food on the store, on the shelves. And so, you know, the gas station where he bought the fuel. I mean, we could go really deep in this, and we really are all connected on that, and we're connected to this straw bale somehow. But growing that straw bale, cutting that straw bale, harvesting the grain off of it, putting it in a bale, storing it somewhere, paying for whatever lighting on that, and then putting it in a truck, driving it all the way up here, the amount of energy that it took for all of us to go ahead and move these straw bales, the person that pays us that had to go do other work. And so really it can go pretty far down the road. And so that's the importance of asking the appropriateness question. So, and so the impacts actually grow quite a bit. So when you look at sizing of houses, and you start to think about embodied energy, and you start to think about consumption over the life of the building, we've got bigger and bigger and bigger, and families have gotten smaller and smaller and smaller.
That's an interesting statistic.
And so our houses are big, and yet we haven't really changed a conventional wall system since the baby boom. There's been little changes in things, but we know how to change this. But the code says you could just do this. And not that I think code should enforce everything. I think more an understanding, give understanding to the people, and they'll start changing. And it's the other thing, it's like peak everything. We're like peak everything. Peak water, peak oil, all of it. And so we know that we are approaching, or perhaps even past, a tipping point on the world in so many different ways. To the point that you might just want to build a very small straw bale house in the middle of the mountains and just hide. But there's other opportunities. So the tank's almost empty on that. And so, that's a great cartoon. Please wait, we're drilling. And, it's funny now, but we've been through this. In the 70s we've been through this. And, we're going to go through it again. So, I think that's going on right now, actually. So there's all these unintended consequences as a result of our buildings. And our buildings are resource sinks. So that's the important thing, is that these types of buildings tend to be, the way we use materials, and what we're trying to do is understanding what resources we have available and how to do that. So we have all these resources, and it's just going in here. I mean, all the forest, all the trees that grew all of these, and everything that goes on in this house. It's a lot of resource to go into it. And it also is a waste generator. It just produces waste. And you don't see a big dumpster on this job. It's because we don't have one. What we have is garbage cans, and we have a scrap wood pile. And we really have not produced very much waste. We really have not produced. We are very careful with the wood. The wood that can be burned, it's going to go and be used in somebody's wood stove, so we'll at least get the heat out of it. The other thing is that you also will not see a lot of manufactured lumber. The plywood in this floor has glue in it, but one of the metrics that we built this house with was to keep as much chemicals out of it, and glues and formaldehydes. So rather than use OSB and engineered floor choices and everything, the homeowners really preferred to use solid wood. Cost a little more expensive, takes bigger trees. The chipboard, actually smaller trees, it's a little bit better in one way. So one, you got a lot of chemicals, but doesn't use up big trees. The other way, you really don't have much chemical at all and takes bigger trees. So our buildings are huge waste generators, though. And so knowing the seriousness of the situation that we face in regard to climate change, energy, water, and other critical resources, human and ecosystem health, population, development, and economic pressures should lead us to reevaluate our options. And really, if we could get folks to reevaluate options, that's all. Just consider it. Because what we lack is not brilliant people. We lack an understanding. We have a lot of knowledge, but we really don't have an understanding. Because if we truly understood all of the impacts of everything that we choose, we would change immediately. But we have a lot of knowledge, and we don't know what to do with that knowledge. And that's where every single little thing that we do as we start to gain that knowledge, to be courageous and put it out there on that edge and say, I'm going to put a risk here, is so important. Because when you get on that edge, all of a sudden your understanding changes. Your knowledge becomes clearer, and you start to gain an understanding. And the understandings are not that black and white. So there is proof that global warming is happening. And so these are swimsuits over the course of time. So we know that is true. Why care? If you do not change direction, you may end up where you are heading. Nothing we do can change the past, but everything we do changes the future. So there's some valid assumptions that are in there. I wonder if we can pull that, if we pull that back, can you guys still see this?
Probably, yeah. You get some warmth, huh?
Yeah, why don't we, there's a heater right there, right outside.
Yeah.
Here, Effa, there's sun. Yeah.
There you go, bud.
You bet.
Yeah, I have the best hay bale. I mean,
Straw.
bale. Sorry.
So we have some no longer valid assumptions. They're critical, but they're no longer valid. We know a stable and predictable climate. We could argue things all day long with anyone in the world, but we can't predict it. We never have been able to, and so it's foolish to think that it is, and we're seeing signs of instability. Adequate and affordable supplies of energy, water, food, and other critical resources. Natural systems on Earth are robust enough to withstand whatever humans may choose to do. And that's a really important one, because even if a person believes this right now, let's come back in a few generations and ask if they've experienced that differently. Current regulatory systems are adequate and sufficiently integrated to deal with emerging risks. And so that's an assumption that we just trust. And it's probably not true. Great modern myth, we need to recognize and address that the great modern myth that we know what we're doing and are in control. We don't, and we're not. We could have the intention of minimizing the unintended consequences and make that part of our decision-making process. And this poetry and slide is from a fellow named David Eisenberg. A bunch of these are actually David's quotes in here. Addressing the great modern myth, thinking deeply about our choices of materials and systems might lead us to develop a preference for doing things as locally as possible, as simply as possible, and doing as little as possible of those things that we know are harmful or about which our knowledge and understanding is limited. And so appropriate technology, the appropriateness. Appropriate technology is the lowest or simple level of technology that can do the job well. Appropriateness relates to where and for what purpose technology is used and the cultural, economic, ecological context. The foam right here, it's insulation. It can do the same thing. It's easy. It's one sheet. We put it up. We nail it in. You know how much work it is to work with these things? They're heavy. It's scratchy. And that stuff's really easy. And I can go to the big box store and get it. Or I can go to the, you know, but there's not much there.
Where's your straw coming from?
San Luis Valley. This comes from a baler down in San Luis Valley who's a subcontractor. It's wheat or barley. And the barley, we never know which. They're so similar, we can't really tell. In fact, we've had wheat and barley next to each other, and you could not tell the difference. The barley goes to Coors, and the wheat goes to ConAgra. And so, you know, we have the byproduct of beer and bread. So,
So I'm going to ask a stupid question. But
Sure.
The question's stupid, right?
no.
Straw and hay.
Yeah,
That's the difference.
we might get there here. I'll answer it now in case that slide's not in this. Hay is grass. Hay is for horses. Straw is for houses. That's
Why can't you use hay? Then
You
can
can.
buy it right here.
Well, you can. Well, it has been done, I should say. It's not the best choice because hay still has moisture in it. Yep. And when people say, "Oh my gosh, what about spontaneous combustion?" That happens in hay. It doesn't happen in straw unless the straw is green or really wet. Straw is dry. So hay is food. Hay is grasses. And there's nutrient content within the actual grass itself, whereas straw is the stalks of the cereal grains. And so there's no nutrient in the actual straw. And so straw comes with cereal grains. Barley and wheat are the two most common that we have in our state. Rice is another one. Rice is fairly common in California. Oats is another one. I haven't heard too many oat straws here. Down in New Zealand, they use a lot of oat straw. And then the other one is rapeseed, which is canola. So you can use canola, that rapeseed, and you can use the rape straw.
When you harvest hay, you have a moisture sensor, and you jam it into the bale to see what the moisture content is, because you don't want to bale it too wet, it'll mold or combust, or both, and then not keep, because you want to be able to sell it 2 or 3 years down the road covered. So I don't remember the percentage on the moisture.
I'm not sure for hay, but we use the same. We have a hay moisture meter is what we use. I didn't bring it, but we have the same thing and we test it. We do. Less than 20%. Almost all our straw comes in at 10 to 12%. And the mold and moisture that affects straw is the same moisture percentage as it is for wood. So once you get above 20% moisture, you'll start to get mold on wood as well as straw. Straw is very high in silica content. So, you know, mice and things. The only one that ever could be considered used for food is oat straw. But it's not a good, stable, everyday type of thing. But this, you wouldn't want to eat this. There's so much silica in this. And so this isn't really good for anything else. Hay is actually good for a lot of other things. It's food. You know, this is not food. So if you let the hay dry enough and you've stacked it and things like that, it could be used, and it has been. It's just not our choice. Straw proves to be much better, and it's a waste product.
And I would say the tensile strength might not be there as well because of the variety on the species.
Yeah.
But it depends on where you get it.
It depends on where you get it. And that depends. Straw also is not all straw bales are created equal. So we buy this. There's one baler in the San Luis Valley that bales, and most of the straw bale builders buy it from him.
What's his name?
Albert Francis. He's in Center. Yeah, he lives in Alamosa. His ranch is in Center. He does. Well, he bales. I don't know if he bales all of them this tight, but he does bale a lot of bales and stocks them and holds them and keeps them really tight and really dry for bale builders. And bale builders all over the state in the Four Corners know about Albert, or they call me actually and ask me because I'm the director of Colorado Straw Bale Association. And so.
Shed where you store excess, or you order?
We don't. We just pulled. We have a bunch of excess because we always have excess on them because it's in the San Luis Valley and it's really hard to go get them.
Ranchers would buy that from you.
The
We
straw?
would buy your excess.
Good. We
I'd
should
rather
talk.
get it from you than
Yep.
go down to the valley.
We've got really good straw, and we probably, I don't know what we have
We
for
need it
leftover.
For calving something awful. We can't get any down there.
Oh,
And
I've got free stuff for you, and I also have bales if we could talk if you're interested in them, because I need a second market because we always have to order extra, and then either hold them for the next bale building and sell them to the next customer.
You guys remember Greg, right?
Yeah.
Greg said I was supposed to ask you for.
You did. You did. You know, if security is our goal, strengthening regional and local self-sufficiency is essential strategy for us and everyone else, everywhere else. And that's a really important piece. It's a really essential strategy, not only for us, but for everyone else, everywhere else. And if everyone around the world is supported in security for the localization, we wouldn't have the issues we have worldwide. Embracing local capacity of people and their communities to meet their own needs also shortens vulnerable supply lines, creates more robust and resilient supply systems, supports vital, durable local economies, and supports healthy cultural, political, and social structures. When we don't have inexpensive, abundant energy to drag materials around the world, process them as much as we can imagine we need to, and drag them around the world some more, it will become crucial that we learn once again how to use well those resources that are available to us where we live. The rules and the way we think about risk and benefit will have to change to become more nuanced, more inclusive, and more responsive to these realities. Green building and more sustainable development offer greater opportunities for local economic development, job creation, and greater community self-sufficiency. Reducing the amount of money flowing out of our local community for energy, materials, and other activities means more wealth is created locally and stays in the community. Sustainable building encourages context-based design, appropriate not only to the land, climate, and available resources, but to the social and cultural fabric of the community as well. Which brings us to how we do that, which is a triple bottom line. And so it's not just about the environment, it's about people, planet, and prosperity. Have you chatted about that, triple bottom line stuff? I'm going to kind of let this do its thing here because I think this is a pretty long slideshow. And so it's really about trying to balance all of these things. And so we see this great sustainable building movement in the culture, in the built environment. We see things such as LEED certified. Well, we think that, you know, a typical code building is right here. You know, I built a code home. Congratulations, you could do no worse. It's illegal to do worse. So just building to code. And then there's these standards to get up to other standards, you know, and we get up into these green building standards that are up in here and certifications that recognize that. And then there's kind of these restorative type of buildings as well. And so looking at sustainable building looks at all of these different things. Site, water, energy, materials, environmental quality of air inside, total environmental impact, community. We've got some goals. And so what about the first natural builders? What about the beavers? What about all of these people? For too long we have judged our innovations by whether they are good for us, which has increasingly come to mean whether they are profitable. Now, we have to put what is good for us first and trust that it will also be good for us. The new question should be, will it fit in? Will it last? Is there a precedent for this in nature? If so, the answers to the following questions will be yes. Does it run on sunlight? Does it use only the energy it needs? Does it fit form to function? Does it recycle everything? Does it reward cooperation? Does it bank on diversity? Does it utilize local expertise? Does it curb excess from within? Does it tap the power of limits? And is it beautiful? And that's Jane Benyus for biomimicry, which is another whole fascinating study on that. So there, that's kind of like, here, that's the cheerleading squad. Get excited about this. Where we go. Any questions or comments or observations? Yeah, Dave.
I was just curious with like, I don't know what kind of countertops or bathrooms.
Mm-hmm.
Do you still use porcelain, or do you use local granite or marble for marble? Like with those things that aren't exactly here in the valley, do you go through the company that's in the valley, or are there's some things that you can't buy locally?
It's complicated.
Yeah. And okay.
It's complicated.
And another question I had is, with just doing your seals, using silicone or caulking.
Mm-hmm.
Is that something you still use? With these people who are against the chemicals,
You bet.
Do you have a replacement for that? And so is there that fine line where it's like, okay, we don't want chemicals, but chemical right there is okay.
Yep.
Where's that line? I guess.
I will answer both of those questions in the same. It depends.
Cool.
It does depend. But what it depends on is many different factors. One, what's available. I would say the number one thing that it depends on is budget. It really comes down to budget. Money is still, no matter how inspired, we could sit here for a few more hours until you're shivering and lips are turning blue and just go into like inspiration and we can change the world for a long time. But when it comes right down to it, people have to eat. And we have to figure out a way to shift this paradigm on their court. I can imagine a new game and a new set of rules, and we can talk about it and we can do all of that. But we have to make that change from within the construct of the system that we're in first. It will do no good to spin off and go build a little straw bale mud hut in the middle of nowhere and say, goodbye world, and we can sing Wooden Ships by Crosby, Stills and Nash and sail off over there and leave them all behind. We don't have any, it benefits us, we feel good in some ways because we're not participating in that world, but at the same time we are not participating in that world. And that participation is so important. So simply to answer the question is, it depends on where our customers are at, and it depends on budget. It depends on many different things in that way. But if we can move somebody, it's really hard to take somebody that's never been interested or heard of straw bale and get them to build the most eco-friendly, non-toxic house. It's hard to move people. There are people that will. Once they start to learn, they'll go all the way there. But if I can take one person and just move them a little bit, let's use less toxic paint. Let's move some of this. And so what I've chosen to do, and kind of the tenements of straw and timber, is we're willing to work with everybody. But one of the things is in the spectrum is we have to do better than code. Our bare minimum is an Energy Star rated house. It has to be tested, be able to be tested and verified and certified. So we hold a higher bar on that. And then the next thing is we have to be able to move that slider. And how far can we move you? How far can we get you to the edge of your envelope? Can we present a new envelope? And do you have the budget that will do that? And then the other piece to it is how much am I willing to risk the financial part of running a business? And we run risks a lot. This is not, we would make more money and do better as a profitable business for the bottom financial line if we just whipped them out real quick and we just stick frame houses and we could do that. But what we're trying to do is we're trying to actually stay competitive. One of our goals is to see how close we can build this house with all this straw and all these natural materials and compete with the folks that are doing a stick frame that is just, bought off the shelf type of thing, which is really hard to do.
The students in my class have heard my little story about grass-fed beef, and Greg might have talked about it too, but we would make more money if we put all the cattle on the truck in the fall and sold them at the sale barn, and then the feedlots bottom, and then they go into the national beef system, so they're fed out on grain, and they get the force-fed antibiotics, and they get all that stuff. We would make more money if we did the conventional route, but it does nothing. We live in cattle country, and not one person can buy a steak from cattle raised here, unless somebody like Parker's or unless we give it a shot.
Yeah.
But it's the same concept. If you did the conventional route, yeah, you might finish faster. You might keep your costs down.
Make more money in my pocket.
Yeah.
Longer vacation.
So I have to, speaking for myself, adjust how I define the word success. And how much money does it really require? Yeah. And then how do you find that peace of mind?
Yeah. Yep.
Because you have a little one now.
Yeah. And so the stress becomes how to balance all of that. And that stress is shared with the homeowner. And so to answer those questions a little bit beyond, we have had to make a few compromises in this rim joist, which is this area right here where that floor meets the outside. It's a very vulnerable area that can easily be, we could easily skip over it and short it and do some things that would pass the inspections and things, but it wouldn't create a very high performance building, and we would be leaving a gap in it. And so we can do that with a tape. There are air sealing tapes that we can do, and of course there's embodied energy in that tape, but the tape is $1 off lineal foot. And that's a lot of tape to go around all of that. I can, for the same cost, to have them come, labor and material, to come spray this and leave, I can take that money, and that's how much the tape costs. Actually, it doesn't even cover the tape, but the tape still is a little bit more. And then we have the labor to do it all. So then I have to say, guys, do you want to do this for free? Does somebody want to give an extra $20 to make up the difference? Or I talk to the homeowner and they say, I'd love to do the tape. And I say, great, I'll price it out. And then they say, I want to do this too. And I want to do this and use this tape and this paint and that, like, great, I love that paint. It's perfect. Best stuff I've ever worked with. It's $55 a gallon. Sweet. And then we get all the way down and they go, wow, we can't build that house. And I go, okay, where do you want to change? What do we need to do? And so one of the things I look for is what the values are and the guiding principles. So when we do a design build process, we sit down, and one of the first meetings on the whiteboard is we say, what are your program goals and what are your guiding principles? Because we're going to have to come back to what's most important to make these decisions. Wall system here and what we're doing. So there's a lot of different configurations of how to use straw bale in a wall system, whether it's load bearing with no wood structure, or it's an infill, or it's a straw bale wrap. What we have run up to here is that we only have really 2 or 3 months in the summer to do the outside plasters. And if we get too far into the fall and we have freezing temperatures at night, we have to use all this plastic resources to drape it. And then if it gets cold enough, we have to heat it. So now we're defeating our own values in that. So that's been one issue that we've had. And so if we can side it with something else in a cladding way we can do any time of year, it helps us with our building schedule all year long. And the other thing it does is it gives an opportunity for a homeowner to be able to maintain it, or we can at that point give them more choices. Because if your only choice is stucco, whether it's lime or it's adobe or anything, you have to commit to maintaining that depending on how much maintenance it needs, or painting it, or all of these things. But now if they want to clad it in metal, these folks wanted metal on part of it, and then they wanted wood siding. And so because of their finish exterior design details, said, let's not plaster it and then fur it out and then side it, let's just side it. And this came about a house ago, and this technique we call straw-cellulose. And so this straw-cellulose, it's a combo. So we actually frame the wall. It's a conventional 2x4 framed wall that we have sheeted with 1/2-inch CDX We can't use OSB. OSB has vapor permeability that's too tight because we want a vapor open wall. And that's one of the things with straw bale building and natural building, but specifically with our buildings. We pay a lot of attention to what water vapor does through this wall system. And so we pay attention to what kind of plaster and what the vapor perms are on the inside. So we want this to be tight so that it's tighter vapor permeability, and we want the outside to be more open. So any vapor water vapor that diffuses or gets into the wall, it goes all the way through and it dries to the outside. In our climate, where we have we're heating the inside a lot, that's the mechanism of drive that we want to foster, and we want to nurture to help that to happen. And so the assembly of materials is very, very intentional. You couldn't use foam. We couldn't wrap this house with foam. It would ruin the wall. So we've got CDX plywood, we've got a 2x wall, 4-framed wall, and we have blown cellulose, which is post-consumer newspaper, essentially, post-consumer fiber, so it's all recycled. And the flame retardants are pretty inert. It's boron, like borax, and so not real toxic, not really a loading, bioaccumulative loading chemical that we're concerned with. Whereas when we get into more toxic foams, a lot of those foams, the chemicals, some of the chemicals that make them up are bioaccumulating. That means as they decompose or as it's produced, the waste of them and things like that, they get into the environment, into the soil, and they don't go away. They just keep accumulating more and more and more. So it's not like there is no away for those things.
Do you take the same approach with that with the fireboard?
The drywall?
I thought that was fireboard. I didn't realize that was just straight drywall.
This is just straight drywall.
Okay.
And so so at the top of the wall, what you're pointing out to is drywall cap. Okay. And the ceiling will be drywalled. And that's just because our insulation, our wall system, needs to have an air barrier on all 6 sides. And that's building science stuff, but you want an air barrier on the outside, on this side, top and bottom and either side. So you want to have it encapsulated. You don't want any airspace in there. One is for fire, but the other one is for maximizing the efficiency of the rated R value or assumed R value of any insulation you put in there. And that's true for every insulation. So people, they get the idea that they're going to go insulate their basement, and they take fiberglass bats and they put them up and they go, it's so much warmer. Well, you're not done yet, and maybe you can't finish it, and it's a huge step, and it is, but you still have air moving through that. Yeah. And so you want to minimize that air moving through that. And so that's really what the reason why that drywall's there, and also as a fire stop, so that if we have any issues. Our inside air barrier is some type of stucco or plaster, and it's really the same word. It's stucco plaster. And so we use a plaster inside, and it's going to be somewhere in the neighborhood of 1 inch to 2 inches thick. And so that's heavy. That's a lot of mass. And when you have this much insulation going all the way through the wall, and then you have all this mass on the inside, when you heat this inside, this mass gets warm. And this mass wants to cool. And when it cools, it's got to go that way. It's either got to give its heat back this way, or it's got to give its heat back that way. And it's a lot easier to give its heat back into this room because there's no resistance. Here we have a lot of resistance to that going away. And so when you have a lot of mass, the reason why straw bale with a mass plaster, whether it's adobe or this is gypsum or it's lime, that mass on the inside is a heat sink. It's a place to store a bunch of heat. And so we have high insulation, and we put our mass to the inside. That's why this assembly with straw bale with an interior plaster is really appropriate for cold climate. Whereas when you get into other places, Tucson, for example, things like that, adobe is going to be a little more appropriate, although straw bale works great there. But if you don't have huge temperature swings, an adobe building would work pretty well. But that adobe, all it does is store whatever you put at it. So, so these houses, they modulate temperature very well. if you have a mobile home or manufactured house, then the temperature swings are just so high up and down if they were to follow what's happening outside. But the swings are just so high. In fact, it gets colder inside the mobile home than it does outside. And it gets hotter inside the mobile home than it does outside. It's like a tin can. And so straw bale houses, they don't do that. There's a dampening effect, and it's because of the amount of insulation and the mass that's in them that as the temperature swings, if your outside temperature is swinging like this, your inside temperature in a straw bale is just slowly changing over time. And so once we get a little more sealed in here with doors and once we get drywall and insulation on the lid, this place will just start to heat. It'll get warm just by the passive solar nature of it. And so the design of things that we do is we have the appropriate amount of glazing. You see a lot more glass and windows on the south. You don't see a lot on the east and the west, and very little on the north. So let me show you this wall system. So the reason why we evolved to this is, one is we are the first in Gunnison for sure doing straw cell. This is our second one. We may be the first in the state. I don't know anybody else that has done this, but there's not that many. And I'm working, collaborating with a friend of mine in Vermont. He's done research. He actually kind of turned me on to this idea. His name's Jacob Deva Rakusin, amazing human being. And we've had conversations with some amazing building science engineers over this. So
is it a concern if you did too much metal on the outside, the permeability?
No, because the metal is just the cladding. It's just the rain screen. Our drainage plane is the Tyvek, which is highly vapor permeable. So it'll get back to the behind that and then fall out. So that you can see that wall.
Oh, okay, so there's insulation sprayed behind that.
Yep.
Okay.
So, and this is a great demonstration. So, the first thing we do, and this would be the same on concrete too, is we put a board down here. This is called the toe up, and it's so the bales aren't on the ground, and that keeps the bales a little bit off the ground. We've spent a lot of energy detailing below this to stop any wicking coming up through concrete and things like that. There's an insulation layer here that levels it out. We happen to have some of this foam, so we used it. You could use perlite, you could use straw, you could use you could use gravel. I like using something that's occlusive down on this layer. Upstairs we use straw, but here it's just extra protection on wicking. And then we actually just take nails and put them in. These are 16-penny framing nails, and we put them in as a Velcro, so to speak. And so that grabs it. And you saw how hard it was to pry this off. So that holds it really well. We put our first course of bales in. Then the insulation company came in and ran this netting and then blew all the way down and dense packed that. So we have solid cellulose insulation, literally blown cellulose, and then the cellulose that the bales are made of for our wall system. Structure is carried on this. So then what we do is we take this bale and make this and run this bale in here. Okay. Big bales use big hammers. So we take the persuader, we persuade it to go down, and so we drive that down, and that's one thing. We want really tight walls, so they stay really tight. So the next thing that we do is secure the bale to the wall. And so we take and run baling twine, exactly.
We need a baling twine recycling facility.
We do.
We have so much twine. If you ever need twine,
Okay, that's good to know.
I have mountains, dumpsters full of it. because there's nowhere to, there are other towns that
Kind of
recycle.
plastic stuff.
So we take this and tie it to the wall, and we just, all we do is come through this top string right here. And although we want to pull it tight, and it could be tight enough that it starts to even pull that bale up a little bit, and the weight of the next bale is going to push it down. And that'll carry all the way up to the top, and then that top bale, somebody gets a workout. Because when we get up to those top bales going in on the wall stack, we hit them with the hammer. And we pound them in, and we get them tight, and we stuff. And so the entire wall in this fashion with the straw cell, the bales are actually secured to it.
Now there's the stucco adhered to the bales. And
Right
that's
to it.
holding the stucco and everything to the
Yep.
frame.
Yep. And so the bale, the stucco that goes on here, the plaster, that becomes one big mass of a wall with no joints in it, and then what that does is it creates what would be called a stress skin panel. And when you have plaster on two sides of a straw bale wall, it becomes really, really strong, because now it's not that you have, you know, each straw bale in there. It's the whole thing becomes one big unit. You can no longer take one bale out.
Right, because in that case you're not tying it to the wall, because
Right.
the straw bale just has plaster on both sides.
Correct. And so it becomes this stress skin panel that's in there, that's together, and that holds that. Very, very, very strong wall system. A number of ways to create it, but all of them could become quite strong. The fire qualities, the moisture qualities, all of these things that we talk about with straw. So straw bale wall system has passed the 1 hour and the 2 hour fire rating tests, the ASTM tests, that research has been done. So not a problem with that. But it wasn't just a straw bale wall. It was a plastered straw bale wall. When we talk about the moisture quality of straw bale, it's the plastered straw bale we're talking about. You know, and when you take plaster and put that plaster floor to ceiling everywhere, insects, rodents, things like that, they can't get in. They can't get in and they can't get out. So hopefully they're out of there, right? And there's an R value, rated R value to a dead mouse. I'm sure there is. So if they are in there, so you know this. So that's why they become very, very airtight buildings.
And the plaster, I assume, is somehow sealed to the floor,
Yep.
right?
Yeah, in fact, let's go look at some of that stuff. So we'll continue this bale stacking all the way up, and we do what's called a running bond. And so the next bale will go half in between, just like bricks. We don't stack big tall rows unless there's a real need for that. And the other thing that we really like about this is that, again, we're trying, Straw and Timber Craftsmen, we're trying to meet production lines. You know, we're trying to go, okay, we're doing this in the industrial model, you know, nail guns and, you know, all of, you know, we're trying to actually compete in that. And carving and notching and retying and all of that takes a lot of time. This is really fast. It's really strong, and our walls are incredibly straight before we plaster. So we don't have to go back through and beat them one way, one guy inside, one guy out, you know, trying to get Tetris going. Yeah. It's funny until you're doing it all day long. So the other thing is that we don't notch bales. And so when we do get a void like this, you know, we put bales on either side and then we stuff, and we stuff it really, really strong. So there's no air anywhere in our walls. We just stuff all of this stuff in. And then here, where we can fit 1.5 bales, we bring a bale right over here. We put that in, we cut the bale, and then we pick up what are called flakes. The way the bales, there's actually grain like wood, but in bales. And we pick up the flake, squeeze it and put it in, and that flake is still as tight as this. So we don't waste the time to retie it. In fact, there are some places that we will actually cut our strings after the wall's in, and the little bit of expansion gives a different pressure on the wall, which is quite helpful.
Are you going to stuff this before you plaster?
Yep. So let's go do the tour. And these little sod staples.
And so that mesh is put over
And
the
so-
entire wall before you plaster?
Yeah, because otherwise you have nothing.
No, not necessarily, not over the entire thing.
Oh, really?
Tight bales.
Oh, really?
So, I mean, that'll,
So the mesh is
so it's
like,
pulling it in. So the purpose of the mesh is actually, the purpose of this mesh is actually to engage the plaster and hold it to the floor so it doesn't shrink up, or if this moves. It's sort of, it's building, it's bridging the two, and to give extra strength right here at the top of the landing. It's the same with this, because this paper will get cut out, but this mesh runs behind here, and we'll scribe all that out. But that just, it's nailed to the stringer of the stairs. And so that actually ties the plaster to the wood. And so 3 different materials, straw, plaster, and wood, move at different rates and
So
settle.
We,
Feel how tight this bale is, or any of these bales when you come by.
they're pretty good.
They're tight, and there's a lot of mechanical tooth is what it's called. This is a piece of framing lumber, and this will get the same treatment.
Yeah.
So if we just plastered across that, that would crack
Yeah.
because of the rate of suction, and they move differently.
Uh-huh.
So,
Do you put the plaster on in layers?
yeah, yep, we do
Layers to get the
3 layers. It depends on the plaster, the binder, to get to 2, but generally 3.
3 layers.
There's the scratch coat, the brown coat, and the finish coat.
Oh.
So the scratch is just cover it. The brown coat's the body, that's the leveling, and then the finish coat is just a veneer. And when we do run it, we can run it right through the bales, and when we do run through the bales, we take a piece of PVC, 2-inch PVC, and we use the chainsaw and plunge out and carve a hole, slide the PVC in, and then all of the pipe for the hose bib runs in the PVC. So if it ever ruptured,
It would,
it drains into the PVC, and that PVC, we put a slight downward tilt to it, and it would drain into the plaster skin. And so if you saw water, wet plaster underneath your hose bib and it wasn't leaking, it could be something back in. Then you can get into the wall and find it and disconnect, pull your whole sleeve out, pull your pipe out and put it back in. So here, there's a few different reasons why we can't do that in these walls. And the reason on this is that the hose bib will come into here, the connection will, and then will go down. So we have no interior walls. That's where we do that sleeving, interior walls hitting the outside. But there's one by the door that's going to go in, and this one. So this will get filled with cellulose.
then what, do you run conduit before you plaster?
We run all the electric. Yep. So the electric will take a chainsaw, and we'll usually use this bale, that joint right there, and we'll take a chainsaw and carve out 1.5 inches by a 2-inch deep trench, and then run the Romex in there and use those sod staples to push it in. And then we have a handful of different ways that we can actually mount outlets onto this. So we can grab wood, or we can carve them right into this. You can carve, if they want, we can carve in the corner. We can carve a little alcove, a little niche in there. And so we can do that, and they can, so
Cool.
you're only limited by the imagination and the amount of time.